Cylinders are linear actuators. Their output force or motion is in a straight line. Their function is to convert hydraulic power into linear mechanical power. Their work applications may include pushing, pulling, tilting, and pressing. Cylinder type and design is based on specific applications. A ram is perhaps the most simple of the actuators. It has only one fluid chamber and exerts force in only one direction. It is used in applications where stability is needed on heavy loads. A single acting cylinder is pressurized on one end only. The opposite end is vented to the tank or atmosphere. They are designed so that the load or a device such as an internal spring retracts them. The double-acting cylinder is the most common cylinder used in industrial hydraulics. We can apply pressure to either port, giving power in both directions. These cylinders are also classified as differential cylinders because of their unequal exposed areas during extend and retract. The difference in effective area is caused by the area of the rod that reduces the piston area during retraction. Extension is slower than retraction because more fluid is required to fill the piston side of the cylinder. However, more force can be generated on extension because of greater effective area. On retraction, the same amount of pump flow will retract the cylinder faster because of the reduced volume caused by the rod. Less force, however, can be generated due to less effective area. A double rod cylinder is considered a non-differential type cylinder. The areas on both sides of the piston are equal, thus providing equal force in both directions. An application for such cylinders would be where it is advantageous to couple a load to both ends, or where equal speed is needed in both directions. The cylinder assembly is constructed of a steel cap end head, a steel barrel assembly, a rod end head, a rod bearing, a piston, and piston rod. Tie rods and nuts are used to hold the heads and barrel assembly together. Static seals keep the joint pressure tight. A rod wiper is provided to prevent foreign material from entering the bearing and seal area. Sealing a moving surface is provided by the rod seal, which prevents fluid from leaking past the rod, and by the piston seals, which prevent fluid from bypassing the piston. Fluid is routed to and from the cylinder through the rod end port and the cap end port. Hydraulic motors are classified as rotary actuators. Motors very closely resemble pumps in construction. However, instead of pushing on the fluid as the pump does, the fluid pushes on the internal surface area of the motor, developing torque. Resistance from the load is encountered, and pump flow provides a continuous rotating motion. Since both inlet and outlet ports may be pressurized, most hydraulic motors are externally drained. The four most common types of hydraulic motors are gear, vane, piston, and bent axis piston. Hydraulic motors are rated according to displacement and torque. The first consideration should be torque. Hydraulic motors are rated in foot or inch-pounds of torque per given psi, typically in pounds per 100 psi. Torque is equal to load times radius. Large displacement motors usually have a greater radius for the hydraulic fluid to push against. Therefore, they create more torque at a specific pressure. A hydraulic motor that is rated at 1 inch-pound force per 1 psi is rotating a winch with a radius of 4 inches. Our load is 500 pounds. The required torque is 2,000 inch-pounds. Based on the torque rating of our motor, our operating pressure would be 2,000 psi. The second consideration would be displacement. This is necessary to determine the amount of flow required to rotate the hydraulic motor at the required RPM.